In the previous class, you have learned that there are very few non-metals as compared to metals. Some of the examples of non-metals are carbon, sulfur, iodine, oxygen, hydrogen, etc. The non-metals are either solids or gases except bromine, which is a liquid. Do non-metals also have physical properties similar to that of metals? Let's see. Non-metals are not hard, rather they are generally soft. But diamond, an allotrope of carbon, is an exception. It is the hardest natural occurring substance. To talk about the state of nonmetals, nonmetals may be solids, liquids or gases. Nonmetals have a dull appearance. Diamond and iodine are exceptions. Nonmetals are not sonorous, that is, they do not produce a typical sound on being hit. And nonmetals are a bad conductor of heat and electricity, except graphite. Graphite, which is an allotrope of a carbon, is a good conductor of electricity and is an exception. Now, when it comes to malleability and ductility, nonmetals are non-malleable and non-ductile. Nonmetals have generally low melting and boiling points, and most of the nonmetals have low density. In our previous section, we saw the different chemical reactions of metals except for its reaction with nonmetals. We shall see that now. So, how do you think will be the reaction of metals with nonmetals, and why would they react with nonmetals? Reactivity of elements is the tendency to attain a completely filled valence shell. Atoms of metals lose electrons from their valence shell to form cation, whereas nonmetals gain electrons in their valence shell to form anion. Let's take an example of the formation of sodium chloride, that is NaCl, which is obtained from the reaction between the metal sodium and the nonmetal chlorine. A sodium atom has one electron in its outermost shell. If it loses the electron from its M shell, then its L shell now becomes the outermost shell, and that has a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons has become 10. So, there is a net positive charge giving us a sodium cation, which is Na+. On the other hand, chlorine has 7 electrons in its outermost shell and it requires one more electron to complete its octet. If sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. After gaining an electron, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L and M shells. This gives us a chloride anion, which is Cl-. So, both these elements can have a give and take relation between them. Sodium and chlorine ions, being oppositively charged, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride, that is NaCl. It should be noted that sodium chloride does not exist as a molecule but aggregates of oppositively charged ions. The compounds formed in this manner by the transfer of electrons from a metal to a non-metal are known as ionic compounds, or you can also call it as electrovalent compounds. So, let's see some of the physical properties of ionic compounds. Ionic compounds are solids and somewhat hard because of the strong force of attraction between the positive and the negative charged ions. These compounds are generally brittle and break into pieces when pressure is applied. And ionic compounds have high melting and boiling points, and this is because a considerable amount of energy is required to break the strong inter-ionic force of attraction between them. Electrovalent compounds, or what we call as ionic compounds, are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. We know that the conduction of electricity through a solution involves the movement of charged particles. A solution of an ionic compound in water contains ions which move to the opposite electrodes when electricity is passed through the solution, and therefore ionic compounds in the solid state do not conduct electricity because movement of ions in the solid state is not possible due to their rigid structure. But ionic compounds conduct electricity when present in the molten state, and that's because here the ions move freely. So now to summarize, in this section we firstly discussed the different physical properties of nonmetals which are mostly opposite to that of metals. Secondly, we saw the chemical reaction of nonmetals with metals giving rise to what we call as the ionic compounds, and lastly we discussed about the different physical properties of ionic compounds.